Hi, hello everybody. So this is the video where we're going to cover section 9.1, the ellipse. And this is the beginning of the topic that we call conic sections. So the name really comes from the fact that we are slicing the cone in different locations. So here you see we have two cones, and when we slice the cone parallel to the bottom of the cone, we get a circle. If we increase the angle a little bit more to a certain degree, we get an ellipse. If we increase it a little more, we get a parabola. And when we incline the angle more so that it is perpendicular to the base of the cone, we get a hyperbola. So that's why we call it the conic section. In this video, we're going to cover the ellipse and the definition of the ellipse. The picture is you see down here is that is a set of points we call P in a plane where the sum of the distance from the two fixed points that we call foci, focus 1 and focus 2, is constant. Okay, yes, I know the definition is a little weird, but maybe graphically it's a little easier to understand. So we have this kind of oval shape, kind of an egg-shaped format, and the point is on the blue lines, right, or the blue line right here, where this distance 1 plus that distance 2, the sum of those two distances is fixed around. And that's why we get the ellipse. Okay. Now that definition is not so much important as the shape that we have to become familiar with. So the ellipse is going to be an object like this. Let me see if I can just trace it. Imagine that the two axes are here. And we're going to have two types of ellipses. I'm going to show you in a minute. Either it's going to be sitting on the x-axis, like this previous one, or maybe this picture is a little better. The one sitting on the x-axis and the one sitting on the y-axis. We are going to have a center, just like the circle. It's very similar to the circle. Okay, both have a center. And we are going to have these key points around. We can call them vertices. Usually the vertex is only where the major axis is, but we can call vertices all four. Okay. For the one sitting on the Y, here are the two vertices and here are the two other points. Now, the foci are always on the major axis. So if the ellipse is sitting on the x-axis, then the foci are here. If the ellipse is sitting on the y-axis, then the foci are there. Okay, so two types of ellipses. Now, we're going to begin. So this is the video where we first show you the standard equation of the ellipse centered at the origin, because that's a little bit easier than the other case, the translated one. Okay, so two types of ellipses again. One with major axis on X and the other with major axis on Y. Now, here are the two formulas for it. It's actually only one, and I'm going to show you it's only one because the only thing that's different is A and B. Okay. All right. So first, let's take a look at the one on the left. The one on the left, even though it doesn't look all that much, it has major axis on the x-axis. So it's sitting on the x-axis and the foci are here. Okay. Now, if that is the case, if the ellipse is sitting on the y on the x-axis, then this value here the denominator to x squared is going to be bigger than b squared. So for the ellipse, a squared is always bigger. If the ellipse is sitting on the y-axis, the foci are here, and I'm going to show you how to find them. And the a value here, a squared, is bigger than b squared. Okay, so for the ellipse, a squared always bigger than b squared. And then the distance from the center to the foci is found by this formula right here. C squared equals a squared minus b squared. All right, so we need to know that. The other thing that we need to know is the following. So we already know that the distance from the center to the foci for the ellipse is this. Well, the formula shows c squared, but the distance is c. And that's why you see here 0c, 0, negative c on the y-axis, negative c0, c0 on the x. Okay? Now, the 4 points that we need to be able to find on the ellipse are these 4 points right here. 1, 2, 3, 4, regardless if we have the one sitting on x or the one sitting on y. Now, if the ellipse is sitting on x, then notice the two extreme points are a units away from the origin 0, 0. So all we have to do is take the square root of a squared. The other point, okay, the other point is same thing, b units away from the origin, up or down. So we just take the square root of b squared. For both cases, it doesn't really matter, right? 0a, 0, negative a, b0, negative b0. So this becomes very straightforward if we remember these three things, okay? The a and the b are distance to the vertices to the extreme 4 points on the ellipse, and the c is the distance of the foci to the origin, to the center. All right, so let's take a look at a couple of examples. And it would be nice to see the formulas so that you can see them as I work the problem. All right, so first let me just erase this. All right, so let's begin with something easy. In this video, I'm only going to be doing these three examples because these are the basic problems. And in the next video, I'll show you the translated ellipse, which are the type of problems that you're going to see on the exam. All right, so first case. Example 1, graph and locate the foci. Right, so normally a question about the ellipse would be find the center, find the vertices, which means find the 4 key points, and find the foci. Okay, we don't have to graph, but I'm going to graph it because it becomes a little bit more informative that way. Okay, and on the exam, you may be able to do both. All right, now, so we look at this thing. So we have to recognize that this basic format is an ellipse, right? With x squared over a value plus y squared over a value equals 1. So this is an ellipse. Now we have to determine if this ellipse is sitting on x with major axis on x or major axis on y. Now, the value under x squared is bigger. So this is an ellipse that has major axis on x. So I'm going to graph, see if I can do this. This is very difficult on this software. So this is an ellipse sitting on the x-axis, and I'm going to write the points already. These two are the foci. Here's the center, And here are the four key points that I need to find. Now, this is the standard ellipse center at the origin, and you see why in the next video. So 0, 0 right there, that's the origin. I am going to find now, so the center is 0, 0. I am going to find the four key points on the outside first. Okay, now the ellipse is sitting on X, so this value is the square of the distance to the outer point, right? To the vertices right here. So all I have to do is take the square root of 9 to find the distance here and there from the origin. So obviously square root of 9, 3. So this is 3, 0, x and y coordinate. And this is negative 3 comma 0, x and y coordinate. Now, for these two locations right here, which you can call it maybe the minor axis, the square root of 4, which is 2. So 2 units up from the origin, 2 units down from the origin. So this is 0, 2, right? X and y coordinate, and 0, negative 2. Okay, so I found the four outer points, the two vertices and the other minor vertices. Now I need to find the foci. So here is one focus, here's the other focus. But the formula for the focus is right here, right? C square, A square minus B square, where A square is the larger of the two values, the two denominators. So this is going to be 9 minus 4, 5. So C squared is 5, which means that C is plus or minus radical 5. So the location of the focus, the first one is radical 5, comma 0, right? X, Y coordinate. And the second one, negative radical 5, comma 0, X, Y coordinate. Now, once you find all of these 4 points, the center and the foci, you have finished, right? You probably want to graph the parabola or to indicate that the major axis is the x-axis, okay? And then you're done with the problem. All right, so this is example 1. Now, in the second example, we have an equation that is not in standard form. So this is the type of equation or problem that you're going to see on the exam. Something that is not already in standard form, and you're supposed to put it in standard form. Now, this example is very easy, and it serves just as a stepping stone into the type of problems that we need to do. So you have this equation, and you should be able to determine that this is not a circle because the coefficients are different, which means then it's an ellipse, right? Because that's the one that has similar equation to the circle. So you're going to divide everything by 400. And the reason you do that is because for the ellipse, you need to have a 1, right, on the right side. So I have to divide everything by 400. Now, when I do that, obviously, I don't want the decimal. I want to simplify the fraction. So in the first case, I have 16. And in the second case, I have 25. Right? So we can just check to see if this is correct. 400 divided by 16, just to be sure. Yep, that is correct. Just want to make sure. All right, so now this equation is in standard form. So now we ask ourselves, the very first question that we ask ourselves, is the major axis the x or the y? So the major axis is going to be the value under which the denominator is larger. So on the y square, 25 is larger than 16. So that means that this ellipse is sitting on the y-axis. All right, so now I already know the major axis is the y-axis, so I'm going to see if I can graph this. All right, so just bear in mind that this is very difficult to do it here, but these are the points, okay? So which means my foci are going to be here and there. They're closer to the vertices um, on the same major axis. And here are the 4 points. This one, that one, the center, and these minor ones right here. All right, so I already know that the center is at 0, 0. So center, 0, 0, it's the origin. And now, looking at the standard form, I am going to see, first find the 4 outer points. This value, the square root of this value, 25, are the 2 vertices. So in here, obviously, the square root of 25 is 5. So the location here would be 0, comma 5, right? X, Y coordinate. Location here would be 0, negative 5. Now, how about here and there? The location at those 2 points is the square root of 16. So the positive one is 4, comma 0. This one is negative 4, comma 0. X, Y coordinate, right? So we have almost everything with the exception of the 2 foci. So for the foci, again, I need to use the formula c squared, a squared minus b squared, where obviously a squared is the larger one. So 25 minus 16. So what is that? 9. And which means that the c is the square root of 9, which is plus and minus 3. So this location here is 3 units below the origin on the y-axis, so 0, negative 3. And this location here, which is the other foci, is 3 units above the origin, which is 0, positive 3. So once you find the 4 outer points, the center, and the 2 foci, you are done. So these problems are very short. We can do them pretty easily, so they're not very complicated. And this is all that you have to do. All right, so let's do one more. The last problem, which is similar to the one we just did now. The ellipse, again, is not given to you in standard form, so we have to put it in standard form. 16x squared, 9y squared, 144. So I recognize that this is not a circle because the coefficients to x squared, y squared are different. So it's an ellipse, which means I have to have 1 on the right side, which means I have to divide everything by 144. All right. So obviously this is 1. And let's check what 144 divided by 9 is. Let's not make a mistake here. 44 divided by 9, it's 16. So this is y squared over 16. And obviously, this is x squared over 9. Okay, so this is the equation in standard form. I already know that 16 is bigger than 9, which means that this ellipse, again, is sitting on the y-axis. So the major axis is the y. So I have something that looks like this. And here the key point center, which is obviously 0, 0. These are the 2 vertices. These are the minor vertices. And the foci will be here again. So I'm going to call it F, I'm going to call it F. Okay. Now, the vertices on the y-axis are square root of 16 away from the origin. So this would be 0, 4. And here would be 0, -4, right? On the y. 4 units up or down in the y-axis. The minor vertices, if you can call them that way, would be square root of 9 units away, either to the right or to the left of the origin. So this would be -3, 0. And this would be 3, 0. And the foci again, to find the foci, I use c squared equals a squared minus b squared. So this is 16 minus 9, which is 7, right? So c plus or minus radical 7. So radical 7 units above the origin, so the top foci will be 0, radical 7. And the lower one would be 0 minus radical 7. And that's it. That's all we have to do at this point, right? So in case you have an ellipse centered at the origin. All right, so in the next video, we'll talk about the translations of the ellipse and the variation of the standard equation for the ellipse.